Assalamualaikum to all of you. Today we will discuss chapter 1, the language of chemistry. Okay? As we already know, yes. As we already know, there are so many elements in chemistry, nearby 118 elements so far, and there are so many compounds. How many compounds are there approximately in chemistry? Some are more than that, nearby 5 million. Yes. Yes, so it is very difficult to learn. So there is a particular method, and there is a particular method to name, how to name the different compounds. So chemists use, earlier they use graphic symbols, but it is not such effective. So later on they move on the symbols. Earlier what they do, they took the first letter of the English name of the element. Suppose there is hydrogen. For hydrogen, that is H. But what happened later on, suppose calcium is there, carbon. For carbon, C. But there are so many other elements which start from C, like calcium, copper, chlorine, etc. So now what they did, they took the first letter, okay, and another letter from their name, like for calcium, Ca. The first alphabet should be in the capital and second should be in small. Okay. This is the symbol of calcium. Similarly, so many other calcium. But except this, suppose now calcium is there, copper, cobalt. Now here CO is coming. Okay. So what they did, the symbol of cobalt is CO, but the name of copper was, yes, its Latin name is cuprum. So the symbol of copper is derived from its Latin name, that is Cu. Okay, this is all about the symbols, first letter and second letter. Now the next thing is about elements. Yes, what is element, sir? Group of same kind or different kind? Yes, definitely. Yes, Jibran, fine? Yes. What is element? You can say group of same kind of atom, similar atom, you can say. Okay. Yes, definitely. Yes, what is molecule? Molecule?
It is the smallest divisible component of a compound. Now, what are different elements and molecules?
Yes, I will tell you. Here, in the case of element, only, you can, in simple word, only one kind of atom. Means atom should be of same shape and same properties somehow. But in the case of molecule, here the atom which are combining, it may be of different shape, different size. Okay, means you can say H2O. H2O is the molecule. Okay, here the atom of hydrogen is somehow different from the atoms of oxygen. Okay, fine. So this is your molecule. H2O is a molecule. CO2 is also a molecule. O2 itself is also a molecule. Okay. O2 is also a molecule. In the case of molecule, the atom which are combining, it may be of same or it may be of different. Okay, but in the case of compound, it should be only of different kind of atom. Are you getting anything or not? Yes, give me two more examples of a molecule first. NaCl, yes. Okay. Give one example in which only one kind of atom is there, but it is a molecule. Yes, ozone. Right.
But what is different between element and molecule? Like O2 is also element and O2 is also compound.
O is the element. Okay. Element. Listen. Element may exist in their own form itself. It can exist. O means here what happened? Two atoms of oxygen are combined. Okay. Two atoms of oxygen combined, they form molecule of oxygen. When three combine, then it will form ozone. Like this, simple.
This is molecule of an element.
Molecule of an element, here you can say. Yes. Next is atomicity of an element. Yes. What do you know about atomicity of an element? Yes.
The number of atoms present in an
Number of atom present in the
element.
Yes, you. In an atom.
In an element.
Okay. Number of atom present. Yes, you.
Element. Molecule of an element.
One molecule of an element. Not an element, no? Molecule of an element. Yes, fine. What is atomicity of an element? It is number of atom present in a molecule of an element. Okay. For example, H2. Okay. The atomicity of hydrogen will be 2. Okay. O2 atomicity will be 2. Now the next is valency. Yes. What is valency of an element? Yes, just the combining capacity of any element is the valency of that element. We can calculate the combining capacity.
Is how much electrons an element can share, gain or lose.
Yes, simply you can say. Combining capacity of an element, and we can calculate the valency very easily.
Like we can have the number of hydrogen and number of chlorine and twice
Yes.
the number of oxygen that combines. This is a method for radicals.
Hopefully you are aware from the structure of atom. In the center there is neutron and proton, and there is shell on different shells. On these shells, electron revolve around the nucleus, and electron have negative charge, neutron is neutral, and proton is positive charge. Okay. Atomic number is equal to the number of proton, which is also equal to the number of electron.
Not in every case. Electron can
In most of the case, yes, definitely. This you can say in most of the case.
the electron proton will be there. Proton will number of electron is ions, one is less.
Yes.
Proton will not. Proton will not.
Yes, yes. Yes, what happened? Yes, what is ion? Ion, when any element either lose or gain, okay, one electron, any number of electron, that is the, sorry, it's become ion, yes, definitely. When any element either lose or gain electron, then that will be the ion, okay. Suppose Na, okay, its electronic configuration is 281, okay. So suppose it's lose one electron, okay, so it will become a positive ion, Na plus. Do you know why there is a positive charge on it? Yes, why? Yes, then? Yeah, number of protons. Yes, fine.
This number of protons will be 11 and electrons will be 10, so one will be the positive.
Yes, one will be the positive charge. Yes, fine, good. You understood? You? Ions. Okay, let's see how we can calculate the valency. Suppose let's do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. These are the first 10 elements of the periodic table, okay, and these are the atomic numbers, okay. Electronic configuration means arrangement of the electron in the different shell. As I drawn there, no? There are so many shells. I didn't mention that K11 OP. So many shells are there. Okay, and there is a particular limit. Means how many maximum number of electron can exist in one shell. You know? Yes. How many maximum number of electron that can exist in K shell? Two. Yes, definitely. In the second one, is there any formula to find out it? Yes, definitely. Good.
This is only possible in 20. This method.
Yes, this is up to valid up to 80 now. After that, potassium and calcium, you can say exception. Okay.
After 20, we cannot use this formula.
Yes, we can't use this. SPDF. Yes. Electron, anicon. KLMN. Hydrogen, helium, lithium, beryllium, boron, carbon.
T20 we are not using that N square formula.
Sorry?
We are not using N square formula for T20.
For 20?
T20. So like
Actually it is valid, but what happened when we go to the high atomic number, then there is some exception in this case. Somewhere it is valid, somewhere it is not valid. Okay? Up to 18 there is no doubt, you can apply it. Okay?
Like Bohr said that in the second last shell, unless and until the last shell is filled, only 8 can come. But it is false after 8. More than 8 can come in the second last shell.
Carbon, lithium, beryllium, boron, carbon, nitrogen, oxygen, okay. This is somehow the arrangement of the electron in the different shell, that is KLM. Okay. The electron which is present in the outermost shell, are known as
Valence electrons.
valence electron. Okay. If the valence electron is less than or equal to 4, then that will be the valency. You can say that will be the positive valency. Okay. Yes. Or you can say simply the valency. Okay. And if it is more than that, then what you can do?
Negative valency.
Negative valency.
8 minus 5. Like
Yes.
8 minus n.
Valence electron. So for that, what you have to do? 8 minus valence electron. To get the valency of that element. Okay. Yes. Tell me what will be the valency of fluorine? 1. Okay. And neon? Neon is a noble gas. It is inert. Yes. Yes. After that, ions. When any element lose one electron, then it's either lose or gain any number of electrons, then it will become ions. Okay. If it is losing electron, then it will be the cation, and if it is gaining electron, then it will be anion. Means it have positive charge on it, negative charge on it when it will gain, because the number of electron will be more as compared to number of proton. Yes. Next is sharing of electron. Yes. Do you know there are two types of bond: ionic bond and covalent bond. Covalent bond.
Coordinate also.
Coordinate. Mainly two. These two, you know.
Yes. It is there in chapter 3.
Okay. Okay, leave it. Yes, tell me about the covalent bond.
Covalent bond that join with two elements. Sharing.
Yes, joint. Yes, you. Covalent bond, ionic bond, you know about that? Yes, tell me about the covalent one. Simply you can say sharing of the electron. Why you?
Yes.
In the case of ionic,
One electron from both.
it
One
may
or two. Well, same number of electrons are shared from both.
be, yes, it may be 3 also.
Same number.
Yes, I am saying it may be 3, na? Single bond, double bond, triple bond, so many.
Same number should be there.
Yes. What is ionic bond?
It is in which gain or loss of
Gain and loss of electron.
it is joined
So hopefully you are
forces.
away from it. Okay, let's discuss a little bit about the